Our next speaker is Maxime, talking about dynamic languages, programming implementation, maybe?
Today I'll be asking the question, are we heading towards a dynamic language winter? The notion of winter comes from an analogy with AI, where there's the concept of an AI winter, so a period of reduced funding and interest. The field of AI research has experienced at least two so-called AI winters. What some of you may or may not know is that neural networks were first proposed as far back as 1944. The concept of backpropagation was first derived in the early 1960s, but it took a really long time for the deep learning boom to happen, even though people thought about deep neural networks a long time before the current century. I think something that's also somewhat interesting with this is that there's also a connection with the field of compilers and programming languages. So when the code for backpropagation was first published, it was published as Fortran code. So one of the first high-level languages that had sufficient degree of expressiveness to be able to express tensor algebra. And the modern deep learning boom came about after the Torch framework was released, which incorporates automatic differentiation and was built in Lua, a dynamic language, and eventually ported to Python to become PyTorch, which is the dominant deep learning framework today. So I'd like to start with some disclaimers. I want to take a critical look at our fields. I'm going to share some opinions that may be controversial. I think we could be doing things differently. It's not my opinion to offend you, but I think sometimes it's useful to be able to take a step back. My opinions are my own, and I don't claim to have all the answers or to be able to predict the future. So dynamic language winter, first thing I thought we could do is to maybe take a look at some programming language trends. So the first thing I thought about doing was to look at Google Trends, which provided no useful information. And
it's all right. You put that on a slide.
But then maybe we could look at some programming language popularity indices. Since the TOB index is widely regarded as being bullshit, I thought I would look at a different index. So there's the popularity of programming language index, which is based on tutorial searches, which is maybe a little bit promising. So I produced this graph on an awful logarithmic scale, and we can see that in the last few years, the popularity of Rust and TypeScript, two prominent statically typed languages, has been increasing. And if we look at this data that I carefully cherry-picked, with no scale given on the y-axis, we can also see that some commonly used dynamic languages have been decreasing in popularity over the last 10 years or so. But unfortunately, then if we look at Python, we see that Python makes everybody else look bad and break the narrative that I'm trying to construct, that we're headed towards a dynamic language winter. Python is the most popular programming language today, and it is a dynamically typed programming language. So dynamic languages are far from dead. JavaScript and Python are just as popular as ever. But these trends also take a long time to evolve, so years and decades. There's still a lot of jobs for C++ programmers, even though when I speak to people about C++ programming, I feel absolutely zero enthusiasm. So I don't think we should ignore the signs. Like subjectively, it seems to me that there's some amount of pressure to move away from dynamic languages. I think industry wants to shift away from dynamic languages. I'm not representative of typical programmers. I'm very involved in the blogosphere, the research sphere. The average programmer is probably not a blogger or researcher. It's probably just someone trying to pay the bills and enjoy their lives. But what we know objectively is that DLS is not getting as many submissions as it used to. So it seems like there's a lot of negative sentiment towards dynamically typed languages. I see things like this on Twitter all the time. Dynamic typing is like driving a manual. Static typing is like driving an automatic. Personally, I feel like it's probably the reverse, but whatever. So why the dislike for dynamic languages? I think part of it comes down to bad gambles. So some of the most popular languages today were created around 1995, in the mid-90s, where it seemed like CPU clock speeds were going to increase forever. And there was like this mentality like, who cares about performance? Computers are always getting faster. So, Python was designed with the global interpreter lock, and in some ways, some of these languages have failed to adapt to modern computing realities where single core clock speeds are not increasing forever, and things are becoming increasingly parallel. I think there's also a question of JIT versus ahead of time compilation. So dynamic languages are typically interpreted or JIT compiled, but there's some pressure to move away from JIT compilation. People like the predictability of ahead of time compilation. There's also mobile devices now. You can't really ship your own JIT on iOS, so that makes it more difficult to rely on JITs if you want your apps to run on mobile. There's also a push to make WASM the future universal binary format, but support for building a JIT compiler that runs on WASM is immature and incomplete, and this seems to be kind of intentional. It's been coming for years, but it doesn't really seem to be happening. There's also maybe this notion that static typing is seen by many as superior to dynamic typing because it can detect some type errors ahead of time. I think this is a genuine advantage of static typing. It does make some classes of errors easier to detect, but there's also some unjustified negative sentiment, like the notion that dynamic typing is just bad or unsafe, or as the Rust community would put it, if it doesn't match Rust semantics, it is by definition unsafe. And lastly, I think there's maybe an interesting parallel to make with music school and music theory. So music school puts a heavy focus on classical music at the expense of everything else. So there's kind of a rigid notion of what kind of music is worth studying. So classical, maybe jazz, which is a recent addition. There's this concept of music theory. You go to music school, you study music theory, but music theory is like the theory of Western classical music, which is thought to encompass everything that's worth knowing about music. And maybe there's a notion of classism in there as well, but other musical genres seeing as less sophisticated. Other musical genres come from people with no formal background in music theory, maybe no university background, maybe from poor neighborhoods. So the parallel is that in computer science we have programming language theory with a heavy focus on type theory. Type theory devotes itself almost exclusively to the study of static typing. So Hindley-Milner type inference, which is the theory of typing for languages such as Haskell, ML, and Coq, which is thought to encompass everything worth knowing about programming languages. Popular dynamic languages are seen as historical accidents created by people with no type theory background. They're seen as less sophisticated and refined. And you have a language like JavaScript, which is the language of web developers, people with possibly no university background. And the notion that dynamic languages are untyped, which is kind of a slur, which is just to say that type theory doesn't really have the vocabulary necessary to express their type system. I think it's also important to take responsibility. There's this quote which may have been misattributed to Ford. If I had asked people what they wanted, they would have said faster horses. I think if you ask industry what they want in terms of dynamic languages, they will say faster JavaScript, Python, and Ruby, or maybe TypeScript, which is to shoehorn static typing into a dynamically typed language. But in some ways, I think if you just give industry what they want, you're looking in the rearview mirror. It seems to me there's a declining interest from the engineering community into what our academic community is doing, because there's a perception that academic researchers don't really care about the realities of the engineering world. Maybe because we're looking in the rearview mirror, maybe because there's a lack of novel ideas and innovation. We're optimizing technology based on past use and not really asking where is technology and the world going. There's a strange obsession in this community with meta compilation. How many PhDs, how many papers? It's commonly accepted in this community that meta compilation is a great idea, but there's just about zero adoption in industry because it's considered hugely impractical because of warm-up time, very high memory overhead, and also because those mega frameworks are complicated systems with lots of moving parts. So is meta compilation a solution looking for a problem? I think there's potentially simpler ways to build VMs, and we're kind of forgetting how to build VMs and compilers in this community. So maybe we're losing track of the value proposition, what we have to offer to the world in terms of innovations in the world of dynamic languages. We spend too much energy trying to work around bad design decisions in existing dynamic languages, maybe too much energy working on meta compilation, mega frameworks that people outside of academia aren't using. Not enough time trying to build something that's genuinely new. I think in an ideal world, academics would take risks that the industry doesn't dare to take. But in the modern world, this has become kind of inverted because there's a publish or perish culture which discourages you from taking risks and makes it so you want to take safer bets. Now that I've talked about all these negative things, I think it's useful to think about dynamic language strengths. So where are we here in the first place? I found this comic panel on Twitter and used part of it with permission. So refactoring in Rust is very painful. I also found this on Twitter. So on the left, you have a really simple piece of programming code. And on the right, you have the incantation you have to use for the type system of TypeScript to make the thing compile. So I write code in Rust on a daily basis as part of my job. I frequently run into arbitrary restrictions of the type checker. Rust makes writing cyclic data structures, which are like computer science 101, unnecessarily hard. And I feel like having to fight the type checker is a waste of my time. Statically typed languages can be very restrictive. I often get the feeling like the type system is just getting in the way. You know, it's reducing expressiveness. So static ahead of time type checking is a trade-off. It's kind of like I'm wasting time now during development, so I can hopefully save some time later in terms of debugging and troubleshooting. So I'm trading flexibility for safety guarantees, but I think there's also like different ways of making that trade-off. Like maybe we can build dynamically typed languages that have some amount of ahead of time type checking as well. So how can we innovate? I think it's important to remember where dynamic languages came from. So what's the origin story? Why were dynamic languages invented? Lisp is credited by many as being sort of like the first dynamically typed language, which goes back as far as 1960. John McCarthy was a mathematician. He wanted to express mathematical concepts in code. And so he created a language to manipulate lists and data structure at the algorithmic level. So the notion of a higher level language with garbage collection, so you don't have to think about memory management, which just gets in the way of doing these symbolic manipulations. Dynamic languages have always been about expressiveness. They came from a research environment as a way to express complex ideas concisely by working at the right level of abstraction. So my view is that the success of dynamic languages is not a historical accident. Even if you think about languages like JavaScript and Python, etc., the popularity of dynamic languages exploded with the rise of the web, where you had a fast-changing technological landscape. And so you needed very expressive languages to be able to cope with that. And now Python is exploding in popularity with the rise of deep learning, where again, you have a fast-changing technological landscape. So maybe there's a notion that dynamic languages thrive in dynamic times. And I don't know about you, but it seems to me like technology is not about to slow down. So I'm Canadian, so I had to insert a quote about hockey in my slides. Predicting the future is hard. We can still kind of try to ask the question, where's the world going? There are some obvious trends. So the world is increasingly online. We're seeing more and more distributed computing, more and more complex software systems, massively multi-core. We have neural network training and inference. We have heterogeneous computing. So can you anticipate any other technological trends? I don't hear enough people in our fields talking about these things, asking these questions. I think maybe we could ask the question, can you make the complex systems of the future easier to build? So maybe again, it comes down to expressiveness. I think if you want to innovate, you should talk to engineers. I often get the feeling that academics look down on engineering, but the notion that CS as a subfield is kind of a subfield of abstract mathematics is kind of a bullshit notion, in my opinion. When I went to university and I studied computer science, there were people basically telling me, well, we just happen to do computer science using computers, but computer science could kind of just exist in a vacuum as a branch of mathematics. But I think that's obviously not true. Your entire career revolves around machines designed by engineers, and computer science as a field blurs the line between research and engineering maybe more than anything else. So successful inventions often come out of necessity, and that means applications. So to have impact, it's useful to be in touch with real-world problems. Python's dominance in machine learning. Python is currently the most popular dynamic language, and I've heard through the grapevine that the Truffle and Graal folks at Oracle are starting to invest more in Python because it's the most popular language right now. But I think maybe that's also looking in a rearview mirror. Even though Python is the most popular programming language right now, I think that dominance is unlikely to last forever because Python is actually poorly suited for these kinds of workloads for a number of reasons. So you might think that this is a silly notion, but in the early 2000s, I wanted to do research on dynamic languages for numerical computing, and I was told by multiple people that MATLAB was the dominant language in scientific computing, and the scientific community would never give up MATLAB. But today, where is MATLAB exactly, right? Like, there's been a clear migration towards Julia, R, NumPy, other technologies. So even though these trends take a long time to evolve, I think it's important to remember that things do change and to be open to new ideas. And I'm going to conclude by just bringing up this paper, polymorphic inline caches. This is one of the most influential papers in our fields. According to Google, it has 533 citations. This paper came out of work that was done on Smalltalk and Self, and this is not to say like Smalltalk and Self invented everything in the 1970s. It's more to say like Smalltalk and Self were created by researchers at a time where researchers dared to dream big and create things that were a little bit out there, and a lot of innovations came out of it. So that's it. Thank you for listening.
So we do have time for plenty of questions.
Hey, thanks for the nice talk. I do agree that there's a bunch of trade-offs between dynamic and static languages. But these days we have gradual typing, or we are moving more and more towards that. But are there things that you see that that just won't be able to happen in that space, where like more purely dynamic languages, for whatever that definition should be, would still be able to have innovations that you couldn't have if you were kind of uniting with a more static approach in the same language?
I think that it's, well, what I see a lot from industry is kind of just a notion that people don't want new languages very much. Like they like the idea of kind of like retrofitting a type system into Python, for example, or retrofitting a type system into JavaScript. But I feel like that's not where real innovations come from. I think there's a lot of opportunities that come up if you design something new from scratch. I guess that's what I would say about that.
More by way of an observation, I really like the point you made about expressiveness, and I think that really is key because it has to do with productivity of development of programs. Being able to build more interesting, useful functionality in the same amount of time and expense. And a key thing that's been happening over the decades of computers and computer science is people design a more expressive language. At first, it doesn't run really fast, and then the implementation types dig in on compiling and the runtime system and everything, and they make it go fast. People said there'll never be garbage collection in popular languages. Well, We saw what happened with that. So I'm not sure it has necessarily to do with static versus dynamic, but if dynamic somehow is necessarily part of expressiveness, then I would agree.
Hi. So thank you so much for the talk. I want to pick up on the point that the last speaker made and talk a little bit about what you mentioned about the web platform. So one interesting thing about how the web platform was designed is it was designed to be liberal in what it accepted and conservative in what it executed. And I think that that's part of why JavaScript was designed coming from Self and Smalltalk and other languages like that. One thing that I observed in my career is that when I began programming, I'm self-taught, so I showed up to work for my first job at programming and I asked, what can I do? And I was told, well, JavaScript's a terrible language. Nobody wants to write it. So how about you start working on that code base? And I've developed an entire career around JavaScript. And I know a lot of other self-taught people, a lot of them women, who have entered into careers that are programming within the web platform because they haven't been respected, because the discipline hasn't been respected. And I think it's interesting that we're now entering a winter, potentially, if your thesis is correct, of dynamic programming languages, because I think that those winters might be interesting opportunities for people who wouldn't be able to enter otherwise. And I'm wondering, I don't know if it's going to be the same as it was when I entered into programming, who those opportunities are going to be for. The question I have for you is, like, this is a room full of academics, how could academia sort of bring these kind of ideas like being, what did I say earlier? Liberal with what you accept, but conservative with what you execute. That's a really interesting idea that allows non-professionals to become professionals in those fields. Could we build something like that in the dynamic language space? Because I think maybe this is the most...
Yes. I don't know if it's exactly going to answer your question. I think a lot of us got into programming because we thought it was fun, and there's kind of like a notion of programming as play, playing with code. So making languages accessible kind of fits into that, making systems accessible. I think if ultimately you can't really stop innovation. Like if you build a system that has less friction and that has like a real value proposition, people will adopt it. It's kind of like an unstoppable force. You just have to have like a good value proposition. If academia wants to design languages that people will use, I think they need to make them accessible. And part of that means like really simple things. Sometimes like making the system easier to install. Like if you publish a project, a system, and in order to install it, people have to run 20 commands, very few people will actually run the system. So accessibility comes in many different forms, not just the language, but also like having something that's conceived with pragmatism in mind.
Thanks. Thank you. It was a great talk. Kind of resonates with me even more because I'm recently actually more on the engineering side. So I like the points about how academics and engineers should or could work together. But I think there is one aspect of what you said which omits a rather important point. So you mentioned about expressivity and being able to write faster and prototype, build better, or no, actually faster was probably the word. Using dynamic languages as opposed to like those that have a static type system that stand in your way and such. So the aspect that I'm talking about is cost. So it's not always just a trade-off between the time you spend fighting the static type system and then after the fact debugging or finding bugs. It's what happens kind of as a result. And in industry, dynamic or problems that happen at runtime can be very, very costly. So there's like an extra layer to it, and that's why I think that maybe there's space for both, right? I mean, there's dynamic languages you can use for prototyping and doing things faster, but in a certain setting, whereas statically typed ones maybe are better suited for like critical applications and those that if you make a mistake really cost you a lot.
Yeah, I think that's a very fair point. Like I guess my my answer to that would be, I think it could be possible to design a language that has dynamic typing but static type checking, essentially.
I think I agree. I'm just saying that you mentioned the trade-off of Rust bad because it tells you too much about what you're not supposed to do versus say JavaScript, which allows you to do almost anything you want. But again, there's the cost involved in writing code in one.
That's a good point. I'll let Jan Vitek come up.
Thank you for the very interesting talk that actually puts these questions on the table. And I think it's more like around related to the comment of our colleague earlier and to your talk definitely. I think it's like the expressivity, it's not the theoretical expressivity. What we should think about is the gap in between our minds and what we want to express in our formalism. Lambda calculus, it's dynamically typed. It was invented in the 30s to think about computable functions. You have Lisp, as you cited, dynamic typed to think about mathematics, whatever. Smalltalk, invented for, amongst the problems was simulation, where you had these objects like planets and whatever interacting. Now, what is the next metaphor that we have in our minds that we want to translate in things? And for that, in Coq, for instance, the tactic language, the historical tactic language, it's dynamically typed because they were exploring ideas and they were trying to play with things and they didn't need the barriers of maybe maturation that then you want to add some rigor, some engineering into your prototyping. So yeah, I think these are some things that we should bear in mind.
Yeah, I think in terms of like things that are next thing we want to express, I know one thing that's really hard to express right now in any language is we're having systems where we have more and more heterogeneous computing. So we have all these different adapters, and like the way you interact with a GPU is by like sending a program over in a different programming language in a textual format, and just the interface is just very, very clunky. So like I think we have a very poor solutions to that problem, and it's only going to get worse. So
that's funny because in those contexts, people are starting using things like TLA+, which is again a dynamic type language that helps think about the problem, not about the technology underlying. So
yeah.
Okay, so this time we are done. Thank you so much.